Hello and welcome to the TechBrain channel. In this video, we showcase an exciting new feature about the MongoDB Atlas platform. We'll be looking at how we work with Atlas Search locally. For a while now, it's been the case that if you'd like to work with Atlas Search, you probably need to have an Atlas cluster spun up. And what that means is you need to be online. So what I'll be showcasing today is a way you can work locally. So we'll be using a Docker container. It'll have a single node replica set. We'll be able to create our Atlas search index as well as our vector search index. So we'll be able to do those demonstrations. But first of all, let's dive in. If you're new to the Atlas CLI, this would be a great way to get yourself into the Atlas CLI. So let's start with what's new. Or perhaps a bit of a background. What is the Atlas CLI? Think of it as a command line interface built specifically for MongoDB Atlas. It helps you interact with your MongoDB clusters. If you'd like to spin up a cluster, manage a cluster, you can actually use the Atlas CLI. So why use the Atlas CLI? So a lot of what you can do in Atlas from the GUI, from the Atlas control plane, that can actually be done from the command line. It is going to be quicker. You get shorter feedback loops. And ideally, you'd want to fit this into your continuous integration, continuous delivery pipelines. So those are some of the benefits from working with the CLI. These are the same benefits that we might see when we work with something like Azure CLI or perhaps the AWS CLI. It makes the mundane, the repetitive tasks easier to automate, and you don't need to learn cumbersome routes through the GUI to get the features that you're trying to use. Overall, it's good for productivity, amongst other things, amongst other benefits. So what can I do with the latest CLI? So what I'll be playing with here is essentially how to set up my clusters for search locally, for working with search locally. So to do that, I'll fire up a prompt. So the instructions for getting this done, these are available from the MongoDB website. So I have Docker running locally, and that's one of the key dependencies here. So let me bring my prompt over to that side of the screen. Yeah, I think I can run it from here. So I'll just make sure that I drop to CMD, and I will come here and say Atlas deployments setup. So I'll run it in this mode here, and then I'll get prompted. So what do I want to do? I want a local database. So I'll run with that, and I'll run with the default settings. Of course, you can customize as much as you like. So what I'm doing here is running with the defaults. So I'll go for that. So it starts spinning my local environment, and it's downloading the latest MongoDB image from Docker. As it does that, I can come back in here and just observe what's going on. So I should see a container spinning up in addition to these two containers that I have here. So let's see how far that's gone. So it's downloading the latest image. So let it do its thing. Right. So wait for it to complete the download. So that's at step 2 of 3. So the download of the image is done, as we can see, and we then continue with the next steps. It's created my deployment, and my deployment is available at that address there. So how would I like to connect this deployment that is created for me? So I'll just go for the Mongosh. There are other options there as well. So that should take me right in. Okay, and I am now logged in. So I can run a few basic checks here. So just clear everything up. And I'd like to check the setup. So as pointed out, we get a single node replica set here. So I'd like to inspect my single node replica set. So I'll come here and say rs status status, and we can see that we've got a single node replica set running on that port. So this is ideal for development. Obviously, I can't use this for production purposes. This is for development and testing purposes only. So if you want to use this for production, clearly it's not going to be ideal. You need at least a 3-node replica set. Better if you've got workload isolation, where you've got the MongoT running on a dedicated node. One of the things I was trying to do earlier was to actually look at the MongoT. So the MongoT, as you know, is the process that actually handles the indexing when we use Atlas Search. So it's a bit of a black box when you work with Atlas in the cloud. So here we do have the option of actually asking around and saying, what are the options that I would pass in if I were running the MongoT. So it's MongoT -- version. Let's see what that gives us. It should return some version number telling us about the local MongoT running here. While it's thinking away, we can actually inspect the logs. We should be able to see that it's standard MongoDB logs coming through. And we can see the setup as well, the stats, all the usual thing. You can go with the file system, and that's what my file system looks like. Typical Docker stuff here. So let's see if we've got anything coming back from that prompt. So that's the version number. And next, you might say mongot -- help. What are some of the command line options available? So you can see that the mongot process can be configured with those options. Whether you'd like to run it directly is perhaps the subject of a different video. For now, just to show you how to develop search locally. So I'll move away from here. And clearly, the first thing I want to do is to load some data into my database. Currently, there is nothing here. I've just got the usual system databases. So if I run show DBs, let's clear all of that. These are my system databases. I want to load some data into this database. So where am I loading it to? So I need to get my address. So I'll go that. And this is where I should be loading that data into. So let's try doing that. We'll load our data. So I have downloaded a sample data archive. You can find that from the MongoDB website. And what I'll do here is to connect to that port 53754. Let's go 53754, and we'll do a Mongo restore. So that's us doing a Mongo restore. So yeah, the restore is proceeding as expected. Let's see how far that gets. Does it succeed all the way? So that's the restore. In here, we've got the sample mflix. We'll be doing stuff on the sample mflix. So these demos will create a vector search index. We also create a keyword search index, and then we can search locally. So that's really where we're trying to get to in this demo. Okay, so the restoration is proceeding nicely. So at this point, I should be able to go to my database here and say show DBs, tell me what you've loaded up. So we've got sample mflix and also sample training. So I go to sample mflix, And in sample mflix, I'll say, show me the tables that we've got. So show tables. So we've got the embedded movies. So embedded movies contains vectors that have been computed for the plot field. So I'll say db dot embedded movies. So just be a quick check, making sure that the data has been loaded successfully. So we can see a plot embedding. So plot embedding, that's the vector which has 1536 elements in there. So we can easily check. So maybe I add a projection in here. So projection which says underscore ID is 0. And plot embedding, give us the plot embedding. So plot embedding 1. And we can say x is that, and then x dot length. That should give us the x dot plot embedding dot length. So you can see it's 1536. So you'll be aware that MongoDB supports up to 4096 vector length. So here we're just using 1536. So that's the total number of vectors that represent a plot. So we're taking a plot and encoding that into that vector. Okay, so what's next? So next, naturally, is to set up these indexes. So my data load was successful, as I can see there. So just to recap, that's the command I was running, data archive. And to download the data, I believe I used this command here. So I just curled into that, and then I downloaded the data. So we're good to go. So next, we create a search index. So I'd like to create a search index. I'll create my search index. So the command to do that is what I have here. So I'll say Atlas deployments, search indexes, create. So let's walk through those steps. So I select the local deployment, and I'll give the index a name. So I'll call it default, and the database will be sample mflix, and the collection will be movies. So we're running a search on that movies collection. So it's gone away and created a dynamic index for me. So how do I know it's created a dynamic index? So what I can do is Atlas deployments connect. I can connect to it. It will ask me where do you want to connect to? How would you like to connect? So I'm now connected. And next thing is use sample mflix. And here we should have our movies. And I'll say get me the search indexes. And we can see that we've got that index using dynamic mapping, and we should be good to go. So a query that I can write here is one where I search for a specific bit of content within my database. So first of all, let's look at the collection. So we've got db.movies, and we say find one. So this is an example of a movie that we might be able to find within this collection. So let me put together a query that allows us to search. It's a query using the index that I just created. So I'm using the text operator, looking for anything where in the plot we've got baseball, and only return 5 movies. I'm not worrying with the scores, but we can insert the scores in there as well. So we get the results as expected. Let me add in here a field that gives us the relevant score. So we'll say that we have a score, and this score is going to be the following. So we're accessing the metadata from that score, and here we can say something like search score, and we should see the results coming through. So that's how these movies score based on that criteria that I searched for. So you can see that the highest score is coming first. So that's you working locally with Atlas CLI and Docker. So a nice bit of magic there. As you can see, faster feedback loops. I don't even need to be connected to my Atlas cluster. I can work locally, make sure that everything works locally, and then finally complete that workflow with a deployment to my cloud database. So yeah, this is good stuff. This is nice stuff. Very nice. Okay, so next we'll be using a vector search index. So for a vector search index, we've encoded some data to make it easier for developers to work with that. So you don't have to do any encoding. So we've got the embedded movies collection. So let's dive into the embedded movies collection. This is our embedded movies collection, and this is what a typical document looks like. We have a plot that we've decided to create an embedding for. I need to have an index here, so I'll go and create the index to support vector searches. So this is what my vector search index definition looks like. So I'm creating this index on the embedded movies collection in the sample mflix database, and the fields I'd like to index are the plot embedding, I specify the dimension, and also I specify the similarity algorithm to use when looking up or searching that vector space. The type of index is a vector index. So to run this, what I need to do is to make sure that I have access to that definition. So I'll come out of here. I will run this command, Atlas deployment search index create, and this is where I'm hiding my index definition that we saw earlier. So let's get to create our vector search index. So it goes away, comes back and says, against which deployment are we doing that? Okay, we're doing it against that deployment. And that should now be done, so I can verify. So to verify that the index was created, I could do something like db.embedded movies, and off this, I will then call get search indexes, and I should see my vector search index. So next up is performing a query. Find it. We run our vector search index and we get the results as expected. And this is all locally driven development. So this is yet another fantastic milestone in terms of just developer productivity. So as you can see, that's my vector that I've used. That's the query vector, and I've used it against that collection. So I can continue to do other things, like, for instance, understand the performance of this query that I have here. So I can tag on, for example, and explain at the end with execution stats to gauge the performance. And let's see. So yeah, we can see the various stages that make up the query. So you're able to do all this locally. So the emphasis is really on local development, accelerating that, being able to plug into our delivery pipelines, and also being able to easily set up ephemeral environments for testing. So let's wrap up the demo. So as a recap, we've been able to use Atlas CLI You can use it in three different modes. There is what we refer to as the default, and that's a default interactive mode. And this is where the prompt asks you for the various settings that you need. You can also customize the prompt. You can run in non-interactive mode as well, which is the last option that we see there. So that's what I did. I was running in the default mode, which is I supply the arguments for whatever it is I'm trying to set up. So in conclusion, what we see from the Atlas CLI are shorter feedback loops, faster development of features that we want within our software, and all in all, it makes the integration of these dependencies much easier. Integration of these dependencies within our software delivery lifecycle. Of course, it's highly customizable, which is music to most developers' ears. Okay, so that brings us to the end of this demo. Hopefully you found something useful in this session. Thank you for watching, and until next time, thank you for joining us. Please like, subscribe, and share.